Number 9, a 100-gram sample of a metal was heated to 100 degrees Celsius and then quickly transferred to an insulated container holding 100 grams of water at 22 degrees Celsius. So from here, you should already know that there's a heat transfer, right? So there's an energy transfer. This metal is at 100 degrees Celsius, water is at 22, so the metal is going to give off the heat and the water is going to absorb that heat. So in terms of metal, it should be exothermic. In terms of water, it should be endothermic. So just kind of know how the heat transfer is happening. Now, the temperature of water rose to reach a final temperature of 35 degrees Celsius. Once again, that makes sense. It went from 22 to 35 because it absorbed the heat coming off from the metal. Which of the following can be concluded? So this thing talks something about the whole energy change. Now, before I answer the question, I want you guys to understand the concept clearly, which is going to be, well, if metal releases, let's just say like 1,000 joules of energy, well, then the water is going to gain that same 1,000 joules of energy. So in terms of the absolute amount of energy change, well, it should be the same for whoever's given up and whoever's taken it. So water or metal lost 1,000 joules, well, water should absorb that 1,000 joules, exactly the same. Now, in terms of the temperature change, though, however, well, that should be a little bit different because temperature change doesn't necessarily have to be the same. What do I mean by that? Well, water went from 22 to 35, so that's a temperature change of 13 degrees Celsius. That doesn't necessarily mean that the metal should have decreased by exactly that 13 degrees Celsius and become 87 degrees Celsius. Absolutely not. Well, the reason is the idea of the specific heat capacity, right? Everything has different specific heat capacity, and therefore the temperature change is solely affected by that specific heat capacity. For people who don't know what a specific heat capacity is, let me just put it this way. It's like you can grab two of your friends, someone who has very much patience and someone who has absolutely zero patience. If you keep poking the person who has a lot of patience, well, they're not going to care too much about it. They're going to be like, oh, why are you doing it? Stop it. And if you keep poking, well, they're not really going to get angry or anything like that. Versus if you poke the shit out of the other person who doesn't really have much of patience, well, then yeah, I mean, the person's going to get super mad like in just about 3 pokes. So that's the idea of specific heat capacity. Some substances have a very great capability of handling that heat, like containing that heat, versus some others don't. So metal, whatever that metal is, and water, well, they're different substances, so therefore they should have different specific heat capacities. And that is exactly why the temperature change must be different, though the absolute amount of the joules of energy transfer is the same on both ends. I hope this makes sense. So given that, let's try to answer the question. A, the metal temperature changed more than the water temperature did, therefore the metal, I don't know, right? Yeah, I don't know about that, but therefore the metal lost more thermal energy than the water gained. Absolutely false. See, the second part is what makes it false, right? Because it says the metal lost more energy than the water gained. That just breaks the whole law of conservation of energy. Energy is neither created nor destroyed. So if metal gave off certain amount of energy, then the water should have gained that exact same amount of energy. So that's why A is wrong. Let's look at what B says. The metal temperature changed more than the water temperature did. So once again, I don't know. I don't know the specific heat, so I don't know if it lost more or it changed more or less. I'm not quite sure. But B, the next part says, but the metal lost the same amount of energy as the water gained. That's absolutely correct. The second part is absolutely correct. So I'm just going to hold on to B, and then I'm going to keep reading C and D. C, the metal temperature changed more than water temperature. I don't know. Once again, I don't know. Therefore, the heat capacity of the metal must be greater than the heat capacity of the water. That is absolutely false, right? Because once again, specific heat capacity, simply put, is just a patience level, like how well this thing can handle the heat. So if what they're claiming, the whole metal must be, the specific heat capacity of metal must be greater, well, if the metal had greater specific heat capacity, that just means it can handle the heat better, aka the temperature change should have been smaller. Because it can handle the heat so well, it doesn't really fluctuate in its temperature. So what they're saying is completely the opposite. That's why answer choice C is wrong. Now, finally, choice D. The final temperature is less than the average starting temperature of the metal. So final temperature is less than the average starting temperature of the metal. Yeah, probably because, it lost some heat. And the water. See, I don't know. Therefore, the total energy of the metal and water decrease. Absolutely. See, that second part right here is absolutely wrong. Once again, for the same reason as it is for the other one, well, it says the total energy decrease. No, that doesn't happen. Law of conservation of energy. Energy is neither created nor destroyed. So it doesn't go anywhere. It stays the same. The total energy stays the same. It just went from one guy to another, but the total energy must be the same. So that's why D's wrong. That's why answer choice B should be correct. Once again, the first part, the metal temperature changed more than the water did. I wouldn't know that until I know exactly what metal it is, and therefore what specific heat capacity it is. I wouldn't know. But the point is, the second part where it says the amount of energy being lost versus gained, well, it should be the same on both ends.